Login accepted.
Okay, well, I guess I'm going to get started, and people will come around when they finish their water, beer, breakfast, or whatever they're drinking right now. So thank you, everyone, for being here, and I have to say that I'm pleased to be in a physical event. It's been a while, I guess, for a lot of us. And today I'm going to talk about Kubernetes. It will be a quick introduction, really. Well, 15 minutes, not that quick. So I won't go deeply into details, but depending on you guys, might go a bit faster and might go into demos. We'll see. We'll adapt to you. So first, that's me. My name is Emmanuelle. I am a product manager on Kubernetes products at Scaleway, which is a French cloud provider. And I'm working at Scaleway on Kubernetes since 2019. And before being a product manager and being on the dark side of the force, I was, like I guess most of you, a developer. I guess I got tired of it at some point. And so just to talk about Scaleway just a while, because I don't know if all of you know it. It's, as I said, a French cloud provider. We are based in Paris. We have data centers actually in Paris, in Amsterdam, and also in Warsaw. So we are also in Poland. That's why it was kind of interesting to come here and maybe meet you guys. So we are probably a European company. So that's why we wanted to, well, expand and see how we could answer the issue that you might have in Europe. That's the main goal, is to be like a European-based company. And we are deploying a lot. It's a company that's not that new, actually. It's here since almost something like 20 years. And we started with data centers, hardware, dedicated servers, and then moved to, well, virtualization and cloud, obviously, and now Kubernetes. So, if I want to get started, I'm going to have to start with containers because, well, obviously when you talk about Kubernetes, well, you have to get some basis about the containers you're based on. So just to have a quick show of hands, and just to, well, I guess everybody knows about containers, so I'm going to be very quick on that part. I just want to know who heard about Kubernetes and know basically what it is. Okay, that's good. Who never heard of it? Okay. Who uses it every day? One. Okay, 2. And who used it already, but maybe not on a regular basis? Okay, great. So, first about containers, and as I said, I'm going to be quite quick about this. I'm going to display a scheme that you probably all know because it's on every cloud documentation, it's on Kubernetes documentation, containers documentation, pretty much everywhere, about the story of virtualization. So basically, at first, like at Scaleway, we had data centers and hardware, dedicated servers, and everybody was, well, using dedicated servers at different providers or having their own servers in their offices. And we can talk about some stories about how sometimes fire came when the air conditioning didn't work anymore. So that was before. And for some companies, it's still the case. Then, of course, with cloud, we have virtual machines. So we're used to having another layer of abstraction on which we are allowed to choose a bit more to configure the requirement that we want for our infrastructure. So basically, we have more flexibility. So it's a layer of abstraction to earn flexibility and scalability on a development level. And then we had containers. So yet another layer of abstraction coming on top of that to keep being flexible. And so that's the kind of scheme that you can find on the Kubernetes documentation and pretty much on every documentation. But when you're talking about cloud computing now, really it's like abstraction on top of abstraction, on top of abstraction, etc., etc. So we have data centers with hardware spawning virtual machines managed by hypervisors, which is a very hard word to say. And on top of that, you run your containers on the virtual machines. And if it was not complicated enough, now you have redundancy between your virtual machines, your containers, and all your software. The idea is that the more complex it is on the hidden part of your architecture, the simpler it is supposed to be for developers, for DevOps, and system administrator to build their infrastructure. And that's pretty much where Kubernetes comes in. My word is a little far from me. Excuse me for 5 seconds. Okay, so I guess everybody here uses containers, or at least maybe Docker, hope so, or are there still people installing their software and application directly on their servers on a special room at their office? No, everybody moved to the cloud. Not good. Less fire. Okay, so when we talk about Kubernetes, yeah, I like to write it in Greek because it's cooler. So we talk about container orchestration. To be honest, to me, container orchestration doesn't mean much. Like, it's so short of a definition that when I started using Kubernetes, I didn't really know what it meant. So, where is it supposed to be? So Kubernetes, it's sold as something like a bit of magic. Why? Because when you have an infrastructure, let's say with 3 servers, so 3 nodes, you can display your infrastructure and your application across the nodes. And Kubernetes can help you spread those nodes, spread those applications and containers equally between your machines. That allows you to have a higher availability of your service because obviously if you lose one of the nodes, your applications are still here. So here, for those schemes, I just have 3 different kind of applications, okay, one which is each color, and we're kind of going to play with them. So, as you saw or not, Kubernetes can allow us to spread them equally between the infrastructure that we are using, okay? Also, we can have what we call auto-healing or self-healing mostly used in the Kubernetes documentation, meaning that if you somehow lose one of your application, so let's say here that I have a container that apparently is not responding anymore, and I really don't really know why, and the purpose of Kubernetes is that I'm not really supposed to care why it crashed, well, if it's the only one who crashed. And what Kubernetes is going to do, it's going to say, hey, I needed 2 of them. Now I have only 1 responding, so I'm just going to spawn another one. And so the high availability of my system is still here. When you have hyperscaling application, like, let's say, software as a service to sell stuff, you can have very high demands of availability at some point. Let's say it's Christmas, Thanksgiving, or another Black Friday, and you have on your website who sells stuff or geeky stuff, let's say, and you want to absorb that traffic because usually you have a certain amount of traffic, you have a certain amount of people who are going to come to your website, who are going to use it, who are going to build, and one day it grows really quickly. So how do you do to absorb that charge? Kubernetes, with a bit of configuration, to be honest, will allow to auto-scale your infrastructure. And so if you need more and more application on replicas of your application, it's going to spread automatically. And the thing is, well, once Christmas is done, well, you don't have that many traffic anymore, and you want to reduce it. So the same way, exactly, you are going to have scaling down automatically on your clusters. Here, I display the auto-scaling part on the containers, so on, we'll say later, what we call pods on Kubernetes. But really the thing is, when you don't have enough resources on your nodes anymore to spawn new containers, you also have the auto-scaling and feature on the nodes, meaning that you can go from a cluster with 3 nodes to a cluster with 500 nodes. And at the end of the day, you can scale down back to 2 or 3 nodes if you only need that. So, another cool stuff is that when you lose a node in your cluster, you're going to, well, have missing containers. And the same was before, when the container dies, well, you're going to want to reschedule it. And Kubernetes will always try to schedule the nodes that you need, the number of replicas that you asked for, and schedule them on the nodes that are available. So if the node here is not ready, Kubernetes will just take the same containers and spread them back to the rest of your infrastructure. And what's nice is that it will also be able to auto-heal or self-heal, the same way it was healing containers, it can heal your node. And when you have a managed Kubernetes engine, you're going to have a replacement of your node. So the old one is going to be removed from the cluster, and a new one will be created at its place, and the containers are going to be rescheduled on it. The whole purpose of that is that, I don't know if, well, I'm looking here, and I guess that most of you have already been awake at 2 or 3 a.m. in the morning by your phone call because a part of your architecture is down. And, well, that means that pretty much that can be over, and you can have a good night's sleep. And of course, well, that's within your infrastructure. So here, nothing goes outside. So I was talking about software as a service, about marketing stuff, but you want to expose those services to outside the cluster. So you want people to connect. So what you're going to do is that you're going to expose your service directly within Kubernetes with a service of type load balancer, for instance. And with a load balancer, you're going to be able to reach the containers that you want to reach on the port that you define. By doing that, remember that we had auto-scaling on the applications? And basically, if you have more pods that are created on the same container that is going to be accessible by the load balancer will add it. And this way, your traffic will be spread across all replicas of your service. And the load balancer will be managed by Kubernetes, meaning if there is an issue with the load balancer, in the same way, it can be resuscitated. So, usually when we introduce Kubernetes and that we talk about it, we think that, hey, Kubernetes is magic, well, that's the message that you have when you don't use it. And then you start using it. And you're disappointed. Because the magic comes with big YAML files. Yeah. And that's kind of terrible. So, but don't worry, at some point the magic come back. So you have YAML files everywhere. Why? Because you have a lot of configuration to do. So Kubernetes is a lot of promises. You can do a lot of stuff. You can have a very highly available architecture. But in the end, if you don't write any YAML, you're not going to go very far. So why you should use Kubernetes? First, just want to know here, who are here developers, DevOps? Please, just so I see a bit who's here. Okay, do we have executives, C-levels, people with the paycheck, managers? And by any chance, any data scientist or data engineer or people working with pipelines? Yeah, we do. Okay. So that's the part where I do a confession that when I was a developer, I didn't care at all about the infrastructure. And I'm pretty sure it's still the case for most people and most developers. Because, well, you have that system administrator or DevOps that gets that call at 2 or 3 a.m. in the morning if there is an issue. So when it's not you who are called, you don't care that much. And I want to apologize to all the system administrators I worked with. Because I think that infrastructure is really everyone's issue and that everybody should care about it and should care how it works. First, if you have the paycheck, really, I mean, if you have an application that is scaling from, that needs to scale from 3 nodes to 500 in 10 minutes, it's going to be noticeable in your invoice. So you probably want to know why this is happening and how maybe to, I don't know, optimize that. And obviously, system administrator, architects are the ones who are the most into the architecture, so they kind of have that heavy weight of maintaining it all on their own. And really, they shouldn't. Basically, developers, data engineers are also to be concerned about how their infrastructure works, how it is secured, and that is quite important and something that is quite not that easy to do with Kubernetes. It requires hall, probably airbag, network policies also. A lot of components are here in Kubernetes to help you secure your environment. And no, a data engineer should not be able to access the SaaS part of your application if he only needs the data analysis part. And that was true before Kubernetes, before the cloud, even on our dedicated server and in our small server rooms. It was still true, but just nobody cared. So when you start with Kubernetes, the first thing I would do is that do not try to go too fast, because you will lose yourself. I'm going probably to say a bad thing about the Kubernetes documentation. Kubernetes documentation has been written by Kubernetes people who already know how to do Kubernetes. And if you don't really know exactly the words and the object you're looking for, you're going to be lost in the Kubernetes documentation. And that will be a nightmare. So go there, but not at first. Kubernetes, there are a lot of objects with a lot of purposes and a lot of configuration going with it. So just take it one step at a time, and it will be fine. And at the end, kind of the magic of everything will come back. So just to sum up a bit, you're going to be able to use Kubernetes for a lot of things. So the main thing, obviously, is to have a highly available architecture. But you can do also a lot of other stuff. So the idea is that you can scale. You can have multiple types of instances. You can have bare metal servers and GPUs and virtual machines within the same cluster. You can orchestrate whatever you want and whatever you need on the type of architecture you need within the same environment. And at the end, that's pretty cool. We have customers using Kubernetes for web application, of course, software as a service. We have also a lot of startups working on AI using Kubernetes. The scaling on the GPUs is really interesting. It's cost interesting because, GPUs are expensive, as you probably know. And being able to scale your workload of GPUs from 1 to 10 machines at the same time and then reduce it, it's a good way to improve your costs. And we also have people working in IoT and doing data pipelines working with Kubernetes. As you can do task scheduling, and still the idea is always to optimize and only use what you need. So let's go into Kubernetes objects. And I'm going to drink. So the main object in Kubernetes, I talked about containers earlier, but it's not really about containers. So the main object in Kubernetes is pods. So the thing with pods, it's, yes, yet another abstraction layer which contain one or multiple containers. The idea is that in one pod you share a network and a volume. So the pods, the containers that run into the same pod can have access to the same data. It's kind of a micro virtual machine, if I might say. So you can have as many containers as you want in a pod. And in general, you don't have that much, but I don't know, maybe someday you have a use case requiring it. So I'll try just to see if I have network enough to go into a Kubernetes cluster. I need to zoom in. Okay. So, and that's when I realized that that mic is not really adapted because I need both hands. So here I say that I have Kubernetes cluster already ready, and I want to list the nodes that I have. So just before that, I might just show you that I have a managed Kubernetes engine on my personal Scaleway account. Yes, on my personal account, my name is Bibish. Well, so I have a cluster here, which was the last version of Kubernetes because I built it yesterday. And for those who never used Kubernetes, you have basically kubeconfig file. So the kubeconfig file is the one that is going to be to allow you to connect to your Kubernetes cluster. So yeah, if you wondered, everything in Kubernetes is YAML. Like pretty much everything. You can do JSONs too, but you'll be the only one. Anyway, so I have a Kubernetes cluster and I have my config file to connect to it, which allows me to use the kubectl command to interact with my cluster. The kubectl command is going to not call directly the nodes, it's going to call what we call the control plane of our cluster. So the control plane is composed of a lot of components. It's kind of a Kubernetes cluster is kind of a master-slave architecture. So the control plane will be the master, and your nodes would be all the worker nodes, where you're going to have your pods and application running on. Kubectl is going to call the API server, which is a component of your control plane, and it will just give you all the information and apply all the configuration that you ask on your nodes and on your cluster. So here I'm just asking what are the nodes that I have in my cluster. So I see that I have 3 nodes here with that version of Kubernetes 1.22. And if I want to see what's running on it, yeah, with one hand it's not that easy. Whoa. At least I have Wi-Fi. Okay, so for now it's empty. I have only one service, which is Kubernetes, which since I'm using Kubernetes, it's kind of the minimum I could opt for. And I have a cluster IP associated to it. So basically, it just means that all the nodes of my cluster can communicate through the same network. So if I come back to that, because I don't remember exactly where I go from here. Tac. No, I don't care about the video, I have Wi-Fi. Okay, so as I said, the first thing we have in Kubernetes are pods. But a pod is just one instance of a running container or running containers, and you can't really scale it. So the first object that usually you're going to try and to use within Kubernetes is a deployment. So what's a deployment? It's just a definition of a set of pods with characteristics. Basically, the main characteristic that's going to be is that the number of replicas of each image and container that you want to run. So, for example, here, and I'm going to, well, I'm going to do it at the same time, but you can create a deployment directly in command line. Obviously, if you want to have a reliable Kubernetes environment, you're going to write YAML files. But for demonstration, it's quicker this way. And you can just ask to create a deployment. So I'm going to do it with both ends. apparently I want to chill because I can't write while correctly. Okay, so what I'm going to ask here is just to create a deployment object with the image busybox, which, as you probably do, doesn't do much, and 4 replicas of it. So what's going to happen is that I'm going to build the busybox object with image, sorry, with the command to just ask to write the date every 4 seconds. And I'm happy because it was created, so it means that the Kubernetes is happy enough. And if I look at what I have in my cluster, wow, we have something interesting. It's the demo effect. So we have crash loop backoff, meaning that I did something bad. I don't really know why, so we are going to investigate. That was not planned at the beginning, but let's see. The first thing I want to see first, let's focus a bit. We'll see about that crash loop backoff before, well, after. Is that I want to see where my different my different pods have been deployed. So here, it's a bit big. If I look at, yeah, it's too big. Whatever, it doesn't want to get smaller. So what I see here on my, oh, I did not, that's why I don't have the information I want, sorry. So if I want to look at my 4 pods and see where they are provisioned, here I have my different pods, so which are in error, as I said, we're going to look into that. And we have the node that they are running on. And as we see here, they are scheduled in different nodes. So we see the DID here, so we have this pod and this one that are on the same pod, on the same node, since I have 3 of them. And the 2 others are on the 2 other nodes. So I have my deployment that deployed actually containers across the different nodes of my architectures. If I look a bit more about what I have here, so I created a deployment. That's what I created. As we saw earlier, we already had the service Kubernetes, so that's fine. We have those 4 pods here, which are not fine, but we'll see. And we have another object here that we didn't ask for. We didn't ask for it. It's called a replica set. And basically, when you create a deployment, it's going first to create a replica set object, and then to create pods. Well, the replica set exactly will create pods regarding the configuration that you gave. So the purpose of the replica set is that it's going to be sure that you have the good amount of replicas that you asked for in your configuration. So here I have 4 pods and 4 desired pods, so that's fine, but none of ready because they're in error. So I wasn't planning on debugging, but there is no guarantee I actually managed to debug it. No such file or directory. Yeah, okay. So that's okay. So that's a very simple thing. It's because I forgot 2 characters when I created my deployment. So that's fine. So basically, it doesn't find the directory because I just forgot to say I'm going to give you just a bash command. So just to do it correctly, I'm going to delete my deployment. So in Kubernetes, you always have the same structure. You do kube control, the action you want to do, on what kind of object, and the name of the object. The kind of object, you always have the possibility to write it whole, or you have some shorter way to do. So you can do delete deploy or delete deployment. It will do exactly the same. The same way, you have namespace with ns, etc. So I'm going to delete my deployment, which I called dep1 here. OK, looks happy enough. Everything is gone. And now I'm going to create it with the correct command. Okay. So as we say, container creating, and now they are running. And if I do again quickly kube control logs on it, so that since I asked it to write the date every 4 seconds, well, it's apparently doing what I asked it to do, which is good news. So, going back here. Services. So now I have a deployment, I have replica sets, I have 4 pods, but it's not exposed outside, so meaning I can't really access it from anywhere except from the cluster itself. So I want to expose the deployment outside. How do I do that? I'm going to create a service. So usually when you create a service of type, for example, load balancer, because that's the one that we in production are going to use most. So you have different types of services that you can do, different ways of exposing your service, your containers and applications. But when you're using a load balancer, you're going to create a load balancer object on the cloud provider that you run your, that you're using for your Kubernetes cluster. That will be done by an interface. As it's a component of the control plane of your cluster called the Cloud Controller Manager, so the CCM for shorter version. And so the CCM is kind of an interface with the cloud provider. It's integrated, and it will create the resources that you asked. So basically, when I ask to create a service of type load balancer, the CCM will get the order and say, OK, I know that object. I'm going to create it on, in our case, Scaleway load balancer and Scaleway account. So that's kind of a YAML file to create an Nginx deployment. So very simple and empty web server, and exposing it with a load balancer. So the part at the bottom will be the load balancer configuration, and here I'm just asking to expose it on port 80. And since I'm a bit lazy, also I'm not going to write the YAML, though I assure you it does work. I'm just going to do exactly the same as earlier. I'm going to create the deployment called Nginx with the image Nginx to be very original. Of course, you can use any image that is in a public container registry, but also in a private registry if you configure another Kubernetes object called secrets, where you can store safely your, not credentials, but your API keys to interact with your service. And let's say that I'm going to ask for 3 replicas. Okay, so here I have my Nginx. So I have still my deployment because I didn't remove it, and I have an Nginx one. I see that I have the replica set, I have the deployment, everything is fine. And as we saw earlier here, see that we had ready 0 because it was crash loop back off and error on our ports. And now the replica set can say that all our pods are ready and in a good state. So now I want to expose that Nginx application. So what I can do is just ask kubectl to expose what the deployment, which one, Nginx, on what port, 80. OK, service Nginx exposed. And here, I see that I have a new service created of type cluster IP. And it doesn't have an external IP. So that's the default type of services that you can find in Kubernetes. And right now, it's not exposed outside. And right now, it didn't create any load balancer on my Scaleway account. So I'm just going to want to remove it. And I'll try again. So of course, as I can remove any object that I want, I can also remove services, SVC for shorter, which I called exactly the same. Here. So I see that it's been deleted, and I'm going just to add another parameter here to say that I want a type load balancer. OK. And here, so the type has changed. I have a load balancer, and the external IP is pending. Why is that? Is that the cloud provider didn't allow an IP yet for the service. So I'm just going to wait a bit, and here it is. And now I have an external IP. And basically, well, I'm not going to do a curl. If I go on here, I just call the external IP URL, and I reached my deployment. The nice thing that here you see that the Nginx load balancer, it's plugged with the deployment Nginx. So meaning that if I want to scale up the deployment Nginx, as I said earlier, it's going to be able to spread traffic about as many pods that it created at the end. And to do that, for example, I can just do kubectl. What do I want to do? Scale. What do I want to do? Scale a deployment, which is called Nginx. And I want, let's say, 10 replicas. And here I'm scaling the deployment. And my load balancer, as soon as the container will be running, it will also link to all those pods. The sweet part is that when you're using, for instance, CI/CD, you have sometimes you deploy a new version, and the new version doesn't work. Like you deploy it, and maybe you have a crash loop backup, like I had earlier. Okay, and when you do that, your deployment and your service won't move to the new, won't link to the new containers that are created because they are in error. So while they're in error, they will stay linked and keep sending traffic to the actual healthy pod that you have running. So this way, when it's way easier to manage your rollbacks when you put everything in production. Okay, and another, let's say, object that you want to have at first when using Kubernetes is persistent volumes. So why is that? Kubernetes, as I said earlier, you can have nodes and they can die, okay? And you shouldn't care about them dying. They're going to be respawned, it's fine. But what happens if you actually use the local storage of your node to store important data? Well, your node dies, it's going to be removed, replaced, you lose your data. That's why we always say that Kubernetes is stateless. It's because you can't rely on the local storage. So to manage data accessibility, you need to use remote storage. which is called persistent volumes in Kubernetes. And basically, well, you need to create a persistent volume claim. So you have storage class name, which is different for every cloud provider, and you can also use storage class names that are not related to cloud providers. And those will, in fact, create the different resources on your provider account. And you will have that remote storage linked to your nodes. So if the node dies, the remote storage will just switch and be available on another node. And that storage, you can attach it actually to a pod. So that's how you can have redundancy, and that's, let's say, the first way to manage consistency and persistent data within a Kubernetes cluster. So if you ever want to deploy databases within a Kubernetes cluster, you will definitely have to use persistent volumes. And perfect, I have only 2 minutes left, so it's nice. So here I talk about the first object that I recommend to use if you're ever going to go into Kubernetes. And the first thing to really understand what's happening, describe what's happening, log into the errors, and deploy expose services. That's the basis of any software as a service application that we have nowadays. So that's the first way to start with Kubernetes. There are many objects in Kubernetes. I've been working with Kubernetes for 2.5 years, and I don't even know if I know 10% of it. Probably don't. But you can do a lot of things. So you have also config maps, secrets to store in a secured way your credentials. To access, for example, earlier I talked about the container registry that can be a private one. You have certificates, network policies for securing your clusters. Also namespace, you can have namespace isolation. And, well, a whole lot of objects. If you want to go deeper into Kubernetes, this afternoon, we have an hands-on lab on Kubernetes, which will be progressive, but we will dig into a lot of configuration and how to spread equally your resources in a multi-cloud environment. So basically, everyone coming to the hands-on will have an access to a multi-cloud Kubernetes cluster. And we're going to play with it to see how to schedule properly our workload on different cloud providers with different options. And that will be with a lot of new Kubernetes object, tension toleration, affinity, topology spread, a lot of options in a lot of YAML files. So if you're up for YAML, see you this afternoon. And I'm done. If you ever want a slide, you can get them here.